In this problem, we're looking through the current through this 6-volt battery. Now we're going to do this using Kirchhoff's laws, the loop law, and the junction rule. Now first we're just going to arbitrarily determine the directions of current. Now doing this, we're only going to use one convention. Now I want the currents to end to the positive terms of the batteries. Now this lets me later say that when we follow the current through the loop, we're going to add voltage when going through a battery and subtract voltage when going through a resistor. So our first current, I1, is going to flow up. And now when it gets here, it's going to split into I2 and I3. Now with the convention, we can say that I4 is going to flow up and that I5 is going to flow down. Now, with our junction rule, we can write that I1 equals I2 plus I3, and that I3 and I4 come together to equal I5. Now we can combine these, write them out a little differently, get rid of I3, and say that I1 equals I2 plus I3 minus, that's a 5, minus I4. Now, we have 3 currents, we need 3 loops. Our first loop, we're going to start here at this 10 volt, go around this way, and end back here. So we're going to start 10 volts, we're going to subtract 2 times I1, we're going to add 8 volts. Now we're opposing this current, so we're going to subtract 6, and then minus 2 I1. That completes our loop, equals 0. We say that I1 equals 3. Next, let's go around this loop. We're going to go up through the 6 volts and around. So we have 6 minus 4I2 equals 0, and I2 equals 1.5. Lastly, we're going to go again up through this 6 volt, say that 6 minus 6I5 equals 0, and I5 equals 1. Now we have enough to plug back into this equation and solve that I4 equals negative 0.5. Now we got a negative answer, so this means that what we chose for our initial guess for I4 is backwards. So I4 is actually going to flow downwards. So I4 is actually 0.5 amps down.